Good morning, mathematicians. We are looking at week 33. It is Monday. Our first question says, what shape is shown below? And of course, we're going to explain our answer. We have been studying these quadrilaterals. The very best thing that I can give this shape is characterized by having one set of parallel sides. That has to be a trapezoid. So we are going to say that it is a trapezoid, and it is a trapezoid because of what we just said, because it has exactly one set of parallel sides. That is what gives it away. It gives it that characteristic shape that we know to be trapezoid. All right, let's go to the next one. Elton Prom will sing 473 songs each night on his Pocket Man tour. He will play 63 different shows. How many songs will he sing in total? Well, each night of his tour, he's going to sing 473 songs. Wow. And he's going to do that for 63 shows. Wow, that's a lot of songs. We're going to find out exactly how many as we multiply 473 times 63. Let's do this with the standard algorithm, but if you prefer grid multiplication or area model, you could do that in this little space, and let's see if our answers agree. We're going to start with this 3. 3 times 3 is 9. 3 times 7 is 21. Here's my 1. Carry my 2. 3 times 3 is 12 plus 2 is 14. And now we're going to cross off our 3 and what's carried. We're going to put down a 0 because my 6 is in the tens place. So we need our answers for the 6 to also come and start in the tens place. 6 times 3 is 18. Here's my 8. Carry my 1. 6 times 7 is 42 plus 1 is 43. Here's my 4. Excuse me, here's my 3. Carry my 4. 6 times 4 is 24 plus 4 is 28. And here is where I write that 28. We are going to go ahead and add these values together. 9 plus 0 is 9. 1 plus 8 is 9. 4 plus 3 is 7. 1 plus 8 is 9. And 2 plus nothing is 2. 1, 2, 3, comma. Look at how many songs he is going to sing. That is a lot of songs. He is going to sing 29,799 songs in total. That's a lot of singing. Our next question is Clint Eastwood has eaten two-thirds of his chicken bucket. He plans to finish the rest evenly over the next 5 days. What fraction of the bucket should he eat each day? There's multiple ways that we can answer this question, but my mind thinks about a tape diagram. If this is my tape diagram, this is representing one bucket of chicken. He has already eaten two-thirds of his bucket of chicken. So this is the portion that he's already eaten, right? This two-thirds he already ate. Now he is planning to finish the rest of this over how many days? 5 days. So this part has to be broken into 5 parts, right? This has to be shared over 5 days. We want to know what fraction of the bucket is he going to eat each day. So I really need to know how each slice of this compares to the entire whole. So I would have to divide this into 5 and this into 5. That would mean that in all, this was broken into 15 parts. And he's eating 1/15 each day. That's going to use up this remaining portion if he does 1/15 of the chicken bucket each day. So let's write that for our answer. He is going to have 1/15 uh, each day. We could write something like that just to tie it back to the actual context. All right. Now let's go ahead down and let's try out some multiplication. We're going to start with this one, and we're going to start with our 5 as the first kind of center point of the problem. We're going to do the 5 times 6 and the 5 times 4 and the 5 times 4 before moving on to the 3. Let's jump in. 5 times 6 is 30. Here's my 0. Carry a tiny 3. 5 times 4 is 20 plus 3 is 23. So here's my 3 and I carry a 2. 5 times 4 is 20 plus 2 is 22. So here, really what I found out is that 446 times 5 equals 2,230. But now I'm going to think about this 3. So I'm going to cross off my 5. I'm going to cross off what's carried so I don't accidentally add it again. And I'm going to put down a placeholder of 0 so that my work for this 3 in tens place will also start in tens place. 3 times 6 is 18. Here is my 8 and carry a 1. 3 times 4 is 12 plus 1 is 13. Here's a 3, carry a 1. 3 times 4 is 12 plus 1 is 13. So now I know that 446 times 30 equals 13,380. But the last thing I need to do to find that overall answer is add. 0 plus 0 is 0. 3 plus 8 is 11. Here is a 1 and carry a 1. 1 plus 2 plus 3 is 6. 2 plus 3 is 5. And 1 plus nothing is 1. So my answer here is 15,610. Now I'm going to move on to this problem. Notice there's an extra digit on top. There's not an extra digit in my bottom factor. So I'm still going to have two partial products. I'm still just going to have one magic 0. But yes, I'll have kind of an extra digit to multiply each of those by. But take note, really my structure is not going to be all that different from what I did over here, right? Let's start with 2 as our first center point. 2 times 7 is 14. Here's my 4. Carry a 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4. And 2 times 7 is 14. So I know that 7,217 times 2, or double, is 14,434. And that looks reasonable. Now I'm ready to move on to my 3 as my next center point of problem. Notice I went ahead and put down a 0 just because I wanted us to notice and think about how the bottom factor is really what facilitates how many partial products we should have. 2 digits in my bottom factor means 2 partial products. And when I move on to my 3, just one of those magic zeros, golden zeros, but really it's 3 times 7 is 21. So here is my 1, and I'm going to carry this 2 above this 1 right here that I'm moving on to, right? 3 times 1 is 3, plus 2 is 5. And now I have 3 times 2, which is 6. And now I have 3 times 7, which is 21. There's a lot of digits here. So take special care to make sure that they're all lined up. We're going to add them together. So we want to make sure we're adding the correct digits. 4 plus 0 is 4. 3 plus 1 is also 4. 4 plus 5 is 9. 4 plus 6 is 10. Here's a 0 carrying a 1. 1 plus 1 plus 1 is 3. And 2 plus nothing is 2. Now, where do I put my 0 here? I'm going to go 1, 2, 3, comma, and my answer is 230,944. Those are my answers for these problems. I'm going to go ahead and circle them so that I can clearly see what you intend to be your answer. One more question for today. We're going to circle the pentagons from the shape below. Well, boys and girls, what does it mean to be a pentagon? A pentagon has how many sides? A pentagon has 5 sides. So we need to look and see which of these shapes have 5 sides. Well, right away I can see what does not. This only has one third side, so it's not even a polygon. A polygon has to be made of straight sides. This is a triangle, 3 sides, not a pentagon. This is a triangle, 3 sides, not a pentagon. Now let's take a look. Does this have 3 sides or 5 sides and 5 angles? 1, 2, 3, 4, 5. Yes, it's a pentagon. Does this have 5 sides and 5 angles? 1, 2, 3, 4, 5. Yes, it's a pentagon. Does this have 5 sides and 5 angles? 1, 2, 3, 4, 5, 6. Uh-oh, this is a hexagon, not a pentagon. Here we have 1, 2, 3, 4, 5. Yes, this is a pentagon. Boys and girls, that finishes up our Monday column.